Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're just going to be talking about the unit circle. The unit circle is one of those things in math that people find complicated a lot of the times. They find it difficult to memorize or confusing because a lot of this information is the same, right? If you look at the coordinates on here, you would notice a lot of the coordinates repeat or look very, very similar with each other. So let's go ahead, let's break it down. Let's look at some different strategies to memorize it. And then in the next video, you'll see that we actually learn how to evaluate and find different angles utilizing this unit circle as well. Let's just talk about understanding it first. So realize the unit circle. Unit can be used in a few ways in math. One way it is used is to represent one measurement. When we talk about the unit circle, the measurement that is equal to 1 is the radius. The radius is the distance to the outside of your circle from the middle, from the center of it. That's why you would notice on the unit circle here that there are coordinates. For example, this one over here, that is 1 unit over from the origin. You would notice that every 90 degrees. This next coordinate, which is straight above, is 0, 1. You did not go left or right. You just went up 1. And same idea for these other two. Every 90 degrees, you're just going to simply have a measurement of 1 and 0, depending on which way you go. The other coordinates, then, are all found by using Pythagorean's theorem. For example, if I look at the 30-degree angle, I look at this angle here. Well, we know that the radius is 1. From there, we know that this is a 30-degree, 60-degree, and 90-degree triangle. 30, 60, 90 triangles have a special property. The side lengths are always known. If you don't remember your 30, 60, 90 triangles and their proportions, might be something to look into. However, we know that the hypotenuse is twice as long as the angle on the far side, the one across from 30. So if my hypotenuse is 1, that is twice as long as this other side, meaning this side must be 1/2. That means the x value you could use the Pythagorean theorem to find, or we can know our 30, 60, 90 triangles, and this one is just going to give us square root 3/2. Okay, 30, 60, 90, you might have to look into those a little bit if you need. From there, realize these two values of this triangle are the x and the y value in the coordinate. It's how far to the left and how far to the right and how far up we actually went. That's how each of these coordinates are made, is using different relations of triangles to build the coordinates. The coordinates are something you want to memorize. When people look at the coordinates, though, they get very confused by them because they don't remember which is which. We already talked about the easy ones, the 0 degree, the 90 degree, the 180. We just need to figure out these three here. Whenever I look at these, I notice how they are similar. I notice that each of them is divided by 2. That is for every single case. These three angles are all divided by 2. That is one thing to note that will help you memorize it. The other thing I note is there's a square root on the top of every single one. And while you might say 1/2 does not have a square root on top, well, what if I put a square root on top? That'd be square root 1/2, which is just still 1/2. So by my logic, that still stands. I could say there is a square root 1 over a value of 2, and that would be okay. So they are all divided by 2. They all can have a square root. Square root of 1 is just 1, though, like we talked about. Then when we look at the values, we need to memorize, okay, which ones have the square root 3s, which ones have square root 2s, which ones have the 1/2s. Realize the middle one. The middle one, it has the same coordinate for the x and the y value. It's square root 2 over 2. That will always be true no matter where you're at in your circle. When you go 45 degrees from wherever you're at, it'll always be root 2 over 2. So what I always did to memorize this when I was growing up is I noticed the x values. The x values count down on the top. The inside of the square root goes from 3, 2, to 1 on the top of our fraction. The y values do the opposite. It goes 1, 2, 3. That will always work from the x-axis. You always count from the x-axis. The x values will always count down. If I look at quadrant 4, 3, 2, 1 from the x-axis. Count from the x-axis down in quadrant 3, 2, 1 as well. 3, 2, 1. You can start to see these different patterns. We always look at it from the x-axis up or from the x-axis down to see the patterns, to see the similarities. Okay? Another way you might memorize the coordinates, I see the y value is 1/2. If I looked at the x, that is not 1/2 of 1. So I know that the y value must be 1/2 when I'm right there. That is, in fact, half of this distance in the y direction. Sometimes you might need to visualize where the 1/2 is. The angles is the confusing part for a lot of people, though. We know that our angles are 0, 30, 45, 60, and 90. A lot of people don't like it, though, when we start talking about the radians. Realize, though, just like the x values, your radians count down. Your radians go from pi over 6 to pi over 4 to pi over 3 to pi over 2. Again, counting from the x-axis. Same logic from the x-axis any other direction. It will always count down. 6, 4, 3 in the denominator. 6, 4, 3 in the denominator, going away from the x-axis. And again, you have the 2 in the middle there. Those are the denominators. Let's talk about the top of each of these, though. We know that in the unit circle, 180 degrees is the same thing as pi. We know that 360 degrees is 2 pi. You will always be either 1 unit before that or 1 unit after either pi or 2 pi. For example, if I looked at 5 pi 6, that is 1 unit before a value of pi. So if I had pi and I wanted to go back to that angle, what I am doing is I am subtracting pi over 6. In order to combine those, I would need common denominators. So now when I rotate back, that angle is 5 pi 6. This logic can be used for each of the angles. If I wanted to go from pi and I wanted to continue further to get to 5 pi fourths, that means I started at pi, I added with it 5 pi fourths, common denominator, makes this 5 pi fourths. One thing to note, if your value is larger than pi, 5 over 4, that would be larger than 1 pi, we know that it has to be past 180 degrees. If that value is 1 larger than the denominator, that means you are in quadrant 3. If that value, let's look at 7 pi fourths, is more than that. For example, 7 pi fourths, 7 is further than just 1 unit above 4. I would have to analyze that a little bit. Well, let's think about this. I know that 2 pi would be 8 pi fourths. I know that I am before that. In fact, I am 1 unit less than that. 8 minus the singular pi fourths gets me 7 pi fourths. Your value will either be 1 lower or 1 higher than pi, or 2 pi, or 0. Let's see what I mean by that by looking at another example. The angles, the radians, are the confusing part for a lot of people. Let's look at 2 pi thirds. 2 pi thirds, well, 2 over 3 is less than 1 pi. That tells me that I must be between 0 and 180. This value of 2, though, is 1 less than 3. 2 is 1 less than 3. Therefore, it must be in quadrant 2. If I had something that was 1 larger than 3, for example, 4 thirds pi, now this is larger than pi. It is past 180 degrees. This value on top is 1 larger than the denominator. That tells me it must be in quadrant 3. Let's look at that, but for quadrant 1 and 2. Quadrant 1 is all of your basic cases. It's 0 and then a little bit further. It's 0 plus pi over 4. So I am 1 value above 0. There, that tells me then 1 value above 0 must be in quadrant 1. Let's look at quadrant 4. I know that this is 7 pi fourths. 7 over 4 is much larger than 1 pi. But how much larger? Well, again, 360 is 2 pi. If I were to put this in terms of 2 pi would be 8 pi fourths if they had a common denominator. That value of 7 is 1 less than the 8. So therefore, this one lies in quadrant 4. It is a weird idea to play around with, but this is how we would get used to learning what quadrants they might be in, because if you know what quadrants they are in, you should know the coordinates. The coordinates for each of the denominators is always the same. Pi 6, pi 6. The coordinates are the same. It's just the sign that changes. Remember, based off your quadrants, the coordinates in quadrant 1 are both positive. The coordinates in quadrant 2, the x value is negative. The coordinates in quadrant 3 are both negative, and the coordinates in quadrant 4, the y is negative. If you know what quadrant your angle gets you to, and you know the denominator, you should be able to determine what the coordinate is. You should know the coordinate, and then you can determine the signs based off your quadrants. The unit circle is a little weird. We will continue to break it down in the next video.